Now, Bryan, who represents not only Nestle but the OMAC, the Foundation for Open Architecture, I'd like you to, build about what Satish said on seamless way of looking at HMIs across different machines, safety. Take us through the performance journey. Take us through, how you have seen the world evolve around different standards.
So normally I don't need a microphone in a room this big. Everyone hears me okay?
Yeah.
Perfect. Because I cannot stand behind a podium and talk. I have to move a little bit. My wife often says, if you want to shut me up, plant my feet. Then I can't think. So I'm going to move around a little bit. But I'm coming to you from two different directions. As was mentioned, I'm the head of automation for Nestle. So I wanted to share with you a little bit about our journey to find a packaging automation solution. But I'm also currently the chairman of the OMAC Packaging Workgroup, and I'll talk about what that is as well. That's the group that's helped us at Nestle to find our solution. So we're going to talk a little bit about the journey, the process that we've gone through to get where we're at this point. I'm going to cover a little bit about, first off, who Nestle is, because I think that's important for you to understand why packaging automation is important to us. Then I'll talk about the solution that we found. It's called PackML. Once I've gotten through a little bit of that, I'll tell you more about what Nestle is doing with other people in industry. Because if we were doing this alone, it wouldn't work. This needs to be a collaborative effort. And I'll share with you some of the value and the benefits that you can find from implementing such an open standard. So to start with, Nestle. We're a company of about $100 billion US in sales yearly. We have nearly 500 factories and 400,000 employees. We make 10,000 different SKUs, and we sell about 1 billion products a day. So almost everyone in India can buy one product a day for us. Because this is the magnitude of Nestle. And every one of those products has to be in a package, at least one package. At least the primary package, if not also secondary and tertiary packaging that's associated with that. So that's a lot of packing. And as a result, we need to have a good control on how we manage that packaging operation if we want to be financially successful. So in the past, Nestle has not focused so much on the packaging automation. The reason for this is because we focus mostly on the process. We make our food different than somebody else makes theirs. Different than Kraft, different than Procter & Gamble's food section, different than anybody else. That's what makes us different. That's what we believe makes us better. And so we put all of our effort into how do we control the process. We design it, we own it, it's ours. So we dictate how the automation is done, what PLCs we use, how those PLCs are used within the factory. On the other side, we have not had packaging automation engineers in the past. We've had a very good packaging engineering group that works on things like what kind of materials, what does the package look like sitting on the shelf, how easy is it to open, what kinds of machines can actually make these packages, and how do we put these machines in factories. And then, oh, by the way, where's an automation guy who needs to come and make it all work together? So that's left us with a bit of a gap. And the reason that that gap has come is because we don't own that equipment. We don't make the packing machine. We make the process equipment, or specify it very detailed. Packaging, we buy it off the shelf, mostly. We need a caser, we need a palletizer, a stretch wrapper, we buy those. And because of that, we've left it to the OEM to determine how that equipment needs to operate. Certainly we tell them what kind of efficiencies and speeds and things, but the internal workings of that machine is not ours, it's theirs. It's the OEM's. And so leaving it to them means that we get different technologies. Because if we try and dictate, you will use PLC, whatever it is, the response we always get is, well, that's not what we do. So if you want that, it's going to cost you more. It's going to take longer to manufacture. By the way, we don't guarantee the performance anymore because that's not what we do. We use this one. So we're taking a new direction within Nestle. We needed to look at how can we be most efficient, most effective. And that's not by dictating what technology the OEM needs to use in its machine. So to start with our journey, we started back in about 2008 with this realization that we were headed in the wrong direction with our packaging automation. We started doing a survey of industry to find out what was available. We came across an organization called OMAC, the Organization for Machine Automation and Control, that had an open standard called PackML. PackML made a great promise. PackML said you can use anybody's PLC and make it communicate with anybody else's PLC. So, apologize to those in the room who might be from Rockwell and Siemens, but we can take a Rockwell and a Siemens and make them talk together. That's not normally done. Rockwell and Siemens don't usually work so well together. But we have a lot of both Rockwell and Siemens. So we thought, this is good. Let's try this. So we decided, well, first let me back up. Let me say exactly what PackML does. I apologize. Oh, go ahead. That's the next slide. PackML does three things for us. First off, it defines a state model for the machine. How does the machine operate? It doesn't say what the code underneath is doing. It simply says, if I'm in a hold state, that means something, versus an idle state or a suspense state. So if I'm in a hold state, I need to be able to say, this is why I'm in a hold state. Everybody around me needs to understand that so they can react appropriately. Second thing that it does is it provides modes of operation. Running, jogging, homing, and it standardizes what those mean. Again, so that the machine next to you has an idea of what you're doing. And the third thing it does is it provides information. We call them pack tags. Pack tags are simply I/O tags that have specific meaning. So if I'm transferring my speed to the machine next to me, he knows that the tag is going to be called pack speed, and it's going to be a floating point value. It's not going to be a double integer, it's not going to be anything else. So it makes the communication of information along the line more standardized. So we decided we were going to put this into practice. So we got a hold of our 4 key packaging automation suppliers. They were B&R, Schneider Electric with the ELAB brand, Rockwell, and Siemens. And we put them in a room and said, here's what we want to do. We're going to make a machine, or a line. Each of you are going to program a machine according to the PackML standard. We're not going to use a system integration PLC on top of that, and you're going to have to talk to each other to control this line. We then stood back and waited for the bomb to explode, which we expected it would. Fortunately, they all thought that was a great idea, because that's what PackML was proposing. That's what it was all about, and they all are corporate members of OMAC, so they wanted to see this done. So we put together a very simple line using some just tabletop equipment that had 4 different machines. It had a D-stacker that was controlled by Schneider Electric. It had an RFID reader and turning unit controlled by Siemens. It had a drilling and transfer unit controlled by Rockwell, and it had a pick-and-place robot controlled by B&R. So for example, on it moved colored pucks around a table. The colored pucks each have an RFID chip on them that says what color they are. The only place that's red is by Siemens. But Rockwell needs to know what color it is because they only drill the white ones. They don't drill the red or the black. So they need to know what the color is. They have to get it from Siemens. Well, B&R needs to also know the color because they have to put it on the pallet. The pallets need to be synchronous colors, so a black, a red, and a white pallet. The only place it can be red, because the only RFID unit is in Siemens control. So it shows that they have to pass information around, and it's not just bits. It's not just that I'm on or I'm off. It's actual information that has to go around. So we put this in practice, and then they needed to implement the state model, because that state model would say what it is that they're doing. You know, what state am I in? Am I in an executing state? Am I in a held state? Am I waiting for somebody else to do something? And then they can pass that information. So the way PackML works then is you have the underlying logic that's the OEM's. It's theirs. No one needs to know what's down there. With that, they just have to use the state model that says what state they're in, and the pack tags that just passes information back and forth across the line. Well, we put this all together and we showed it for the first time to the world at Pack Expo about a month ago in Chicago, in the USA. It was a tremendous success. It ran for the entire show without flaw, which was lucky for us because we commissioned it about the same day we shipped it due to some timing issues. So we were a little bit nervous, but it ran well. And the communication was perfect. The information going from machine to machine to control the line. So now that we've seen that it can actually work, recipe screen, well, it depends on which HMI you're on. The recipe screens are found in different places. And the operator has to then figure out how all of this works and put it all together in his mind so he can operate this line. He finally gets it, but heaven help us the day he's sick. Because then you got to put somebody else in that line, and he has no idea. And we see it every time. Efficiency goes down. Production goes down. Because it's too complex. Well, why is that? Why can't we have a standard for HMIs? Something that has things in the same place, the same color schemes every time. This doesn't change the information that the machine builder needs to provide, it just changes where he puts it. So we've developed a template that does things like put alarms and messages down on the bottom of the screen. It puts recipe information up at the top. It synchronizes start, stop colors, reset colors. And it leaves that whole center section for the machine builder to put the information he needs to put for you to run the line. The value of this is now my operators only need to be trained on navigation once. As was said earlier, this is just like Windows. I've got thousands of Windows programs, but you know what? I always know where to find File Open. It's in the same place every time. I know how to print. It's in the same place every time. Why can't my HMIs do the same thing? The recipe screen is in the same place every time. The start and stop buttons, they're in the same place. The operator just needs to know the specifics of his machine. He doesn't need to know navigation differences now. So this is one thing that we're working on very heavily. The next thing would be to be able to take the information these machines can now pass between each other and do something with it. So we're providing the links to MES, the vertical link now, and how to do reporting, things like downtime monitoring, first fault detection, ability to let the maintenance crew see what were the top 4 or 5 downtime reasons and times on my machine for the last shift, to be able to start to focus on where improvements can be, TPM style of manufacturing. We also are working very closely with our packaging engineers and our procurement group to put together a URS, and we heard that term earlier today, user requirement specification. Something then that when I go to purchase a machine from an OEM, I use the same documentation each time. Yes, it's configured for that specific machine that I'm buying, but he always knows there's a chapter on procurement. What kind of terms and conditions do we expect? What's the payment going to be? There's a section on line integration. How do we use PackML? Which pack tags are going to be used? What do the specific states, how do we interpret them? It's got a chapter on hygienic design. We're a food company. What do you need to do in terms of hygiene for us? It's got a section on electrical and automation. What do we expect in terms of wire labels or panel labels or types of equipment to be used in the panel? So we're standardizing all of this. And most importantly, we're putting in there a chapter on how do we validate the machine. If you say that it's going to run at 97% efficiency, how do we validate that? How do we both agree that it's actually at 97% efficiency when we do the commissioning? So we're putting together this URS, and our purchasing group can hand to the machine builder and say, that's what we expect. This is a key thing for us, because now it standardizes. Not only are we standardizing the way that the programming looks and feels for the technicians, we're standardizing how the information is passed back and forth between machines, we're standardizing how the operator interacts with the machine in the look and feel, and we're standardizing on how we purchase machines. We're making this a process then that we now have control over, where before we didn't. We were selecting one from here and and one from here, and then throwing them together and saying, Mr. System Integrator, come make these things work, because we bought a bunch of different stuff and we don't know how to do it. We're controlling that up front now, saying, we know how it works, we know how to integrate it, we know how to make our efficiencies much better. So, as I said at the very beginning, if we were doing this alone, it would fail. It would just be another Nestle initiative that's different from what everybody else in the world is doing. And okay, we win a little bit because we're so big, but we would lose because it's different. So Nestle is taking a position along with other global leaders in OMAC, which is the Organization for Machine Automation and Control, that works on best practices around industry to standardize them in an open format that anyone can use. So we have a vision and a mission. You're going to get these presentations off the website, so I'm not going to go into great detail on what each of these are. But basically, the vision and the mission speak to end users, machine builders, system integrators, and technology providers. All the different sectors saying, we want to help you. We want to make better packaging machines that bring faster time to market for end users and machine builders, that make the, lost our video on one, this one is, that make it easier for you to improve the efficiencies in your lines. So we have some specific goals within the packaging work group of OMAC. The first one is enhancing OEE. And we want to enhance the OEE through 3 different tracks. First is being able to work with international standards, something that everybody understands. Second is to be able to do horizontal integration machines, in other words, line integration, machine to machine. And the third one is vertical integration, machine into the MES and ERP systems. How do we get the information? All right, you dropped everything. Good. How do we get the information from one place into the other so that we don't lose that information, so that management has a better visibility on what's going on within the process? And across all of that, improving safety. Safety in packaging systems, at least for Nestle, that's where we have most of our incidents, is in the packaging side. So we need to find systems that can be more effective and efficient in safety. And to do that, the packaging work group is broken into 2 different arms. We have a technical arm that works with what are these standards, how do you implement them, what do they mean? And we have a marketing arm. The marketing arm is all about what's the business value. The value to you in any of those 4 sectors, end users, technology providers, system integrators, or OEMs. Because there is value for everyone. And that's what we want to focus on, is what is that value? So let me talk just for a few minutes about some of the value propositions that we expect to see for a couple of these sectors, the sectors that are most represented here in this room. First off, for end users, myself, most of the people that are in this room, what is the value that we expect to get? Well, first off, we expect to be able to use an international standard. And with that use of an international standard, hey, we're back on, very good. With the use of the international standard, we are better able to integrate our equipment horizontally and vertically, and then get best-in-class equipment. No longer do we have to tell the machine builder, we need a Rockwell PLC, or we need a BNR PLC. We can say, look, use the technology that best fits your machine. You're the expert. It's your machine. Find the technology that works, but do it with the standard, so that when it comes into my factory, I get the best machine and I can make it work with the rest of the stuff in the line. This is going to reduce my total cost of ownership. So that's the benefit to me. The benefit to the next group, the machine builders, which is equally as important as the benefits to the end users, are just as great. So first off, it allows the machine builder now to select technology platform. We're not dictating it anymore. Let the machine builders use what they know works. With that, it creates much, much simpler post-sale support. Right now, if Nestle buys a packaging machine and dictates that it must be Siemens Automation, and this particular supplier only works with Rockwell, he says, I can't do that. Well, we insist on Siemens, so they'll do it, You pay them enough, they'll do it. But then in 6 months, when I call and say, hey, you got a problem with this machine, what's the first thing that happens? Click. And then they call you back, the guy who built that quit. We don't have anyone else who knows Siemens. Yeah, it's a pain. It's a pain for all of us. Well, if we can just use whatever it is that's their standard, we know we get better support. But the most important thing for the OEMs is that we protect their intellectual property with this. Because right now, when I do a line with different types of PLCs in it, I have to hire a system integrator who comes in, he works with every one of those OEMs to understand exactly how they program their machine. Because he's got to find the bits in that machine that give the permission to the bits in this machine to make them work together. So the manufacturers are giving away their intellectual property to the system integrators. They have to. It's the only way to make it work. Well, with PackML, we don't care how it works underneath the hood. All we need to know is what state are you in, what mode are you running in, and pack tag information. After that, what's underneath the hood? That's the OEMs. System integrator doesn't need to know. He can still plug everything together and make it work. So we protect their IP. That comes to the system integrators, because you might ask them, well, why would a system integrator even want to do this? Because that's what they do. They work with bits and bytes in machines. Well, if you talk to the system integrators, they don't like doing bits and bytes in machines because they never know exactly what they're going to run into. And it's not where they make any money, it's where they lose money, having to get into the guts of the machine. A system integrator would rather have machines that integrate simply and work on things that make the integration better. Value-added tools, things like MES systems, reporting, downtime analysis, things that bring value to the end user, because you know I don't get any value out of bits and bytes in a PLC either. My value comes with the information and what I do with it. And that's what the system integrators provide to me, is this sort of value-added activities. And so the last group then is the technology providers. Obvious for them is that it allows them to focus on what makes their solution better than their competitors and sell to the machine builders based on technological advantage, not based on company X wants this, because that's not an advantage to anyone. And with that, then it opens up the market to the technology providers to be able to go in and say, look, my PLC is better than their PLC because, and the OEMs can listen. Whereas right now, a lot of times they don't listen because they know, well, my biggest customer is Nestle, and Nestle only takes Rockwell. So I can't use what you've got, even though I see it's better. That all goes away. So those are the reasons why an open standard like PackML has value to everyone. It's not just a Nestle thing, it's not just an end user thing, it's something for everyone. It brings a lot of value in allowing us to make more efficient, better machines, better lines across the board. So last slide, just to leave you with, here are some of the companies that are involved in OMAC. This is not an exhaustive list, but it's just a showing to say, look, there's a lot of big companies involved in this. I have stood on a stage with Procter & Gamble, Pfizer, Nestle, SAB Miller, all standing shoulder to shoulder in a symposium like this, presenting together and saying the same thing. We want the same equipment. I want to buy the same caser that Procter & Gamble's buying, because I don't make money off of a caser. I have to put these in a case. I'll make my money off of my product I think is better than theirs. So you can see there's a lot of big OEMs, a lot of big technology providers, and a lot of system integrators. So the message I'll leave you with is, we honestly believe at Nestle that we have found the solution to our packaging automation issues. We believe that by applying PackML, we will have more efficient operations. We are fully dedicated to PackML. We are very much involved with OMAC, and will continue to do so, and continue to drive other parts of the standard as well, so that we have a more efficient line in the end.